Thank you very much. Welcome back to this exciting panel. My name is Alex, Technical Project Manager at CharIN, coordinating the project mining activities at CharIN. And as the panel says, it's not only about technology, it's about our joint journey together as CharIN and ICMM. It started as an initial task force, and then it turned into a structured project mining group. And this journey is important because it reflects a broader industry reality. Mining electrification is no longer about whether it will happen, but it is about how fast and how consistently we can scale it across the industry. So, as highlighted in CharIN's activities, the core challenge is clear. We need standardized, interoperable charging systems to enable safe, efficient, scalable electrification. So, how do we make interoperability real in mining operations across OEMs and infrastructure providers and standards, and use it as the foundation for large-scale electrification? I will discuss these topics today with Vedrana Spudic. She's the Global Head of Technology for Process Industries at ABB and Technology Manager for Business Line Mining and Materials. Then Ian Curran has worked in the mining industry for over 25 years. His current role is focused on BHP's decarbonation pathway for mobile equipment, and he's also one of the key initiators for the CharIN Mining Task Force. Then, to my right side, Will Doherty. He's a prominent leader in the decarbonation field, dedicated to integration, sustainable practices with cutting-edge technology at Komatsu. He spearheads Komatsu's electric drive truck carbonization initiative through the Greenhouse Gas Alliance. Then we have Marc-André Grivix from Grivix, the founder and CEO of Grivix here, as a technology leader in high-power charging solutions for electric heavy-duty vehicles and mining. At Grivix, he leads the development of cooled cable systems and autonomous robotic chargers designed to deliver currently up to 6 megawatt of power safely and efficiently. He's also a key contributor to the ruggedized MCS white paper developed by CharIN and ICMM. Then we have Christian Ebert here, from Hitachi Energy. He's a key contributor to the XMCS white paper. He has held various roles in ABB for power transformation services, and since 2020 he's been the global solution manager for transportation at Hitachi. And finally, Andre Kaufung, managing director from CharIN. He's been responsible for realizing the association strategy and CharIN's vision, empowering the next level of green mobility and energy. The combined charging system, the megawatt charging system, and the North American charging system are the common ground on which the CharIN community has based their achievements on over the past 10 years. So for this session, we will structure the panel into 3 parts. First, we will reflect on the interoperability journey, and then we move into technical deep dive on key charging concepts like the dynamic charging interface, the ruggedized MCS, and the extreme MCS. So let's bring the panel in to reflect on this journey. And the first question I would like to ask Andre is, looking back at the last 3 years, what has been the biggest shift from a CharIN mining task force to a project mining group?
Yeah, thank you, Alex, for raising that question. So we in CharIN, we had a couple of task forces already, and task forces, everyone in the room knows, is something where you need to be quick and do something in a certain, let's say, membership distribution. So for me, the biggest challenge was how is a more or less car-orientated passenger car, and in that time, 3 years back, bus and truck related organization fitting together with ICMM and with the mining industry to exchange lessons learned. And the task force was our first mode to see what requirements are maybe similar, what requirements differ a lot, and how can we help to save time and with time money to find the right steps and evolutions for a charging system or an interface, a protocol in the mining industry. And to be honest, when we started that, it was not clear, is this something we do now for 6 months or for a year or for 2 or 3 years? So I'm quite happy that we, after 3 years, are here and have a significant exchange already within the groups and transformed it from a task force where everyone was invited to join and bring the experience to the table to transform that into a, I call it, real working group, where output is generated, where papers are written, where alignment, cross-industry alignment is done, and where you can see for the future certain steps of the next, from a CharIN point of view, the next charging equipment for mining vehicles.
Thank you very much. As introduced, Ian is also the key contributor to this task force. And from a mining perspective, what does interoperability mean in daily operations, and then how is this a success story for you?
Thanks, Alex. I think, the question around what does interoperability look like and what is good in mining. If you take mining, the fundamentals of mining have not changed. Productivity is still one of our paramount objectives. We need to move material. Most of mine sites are already established brownfield sites. So we have a lot of challenges within that scope. Our cost per tonne is a really important piece of that. Our ability to move material is very important. The congestion within a mine site, as you get deeper and larger, becomes more and more complex, and the ability to install infrastructure in deep pit mines in certain areas with the congestion becomes even more and more complex. So the ability to run multiple OEM pieces of equipment at the one time, in the one operation, under the one set of infrastructure is absolutely paramount. We can't have one charger for one OEM, another charger for another OEM, etc., because we can't fit them into the mine site. We can't get the mines running effectively. We saw in the early days when we first started this work with CharIN, the journey that on-highway vehicles had gone. There was 8 plugs across different manufacturers. Everybody carried a trunk full of double adapters to adapt into the different charging receptacles that were all out there. Again, with the power levels we're moving to, the ability to do that is non-existent, and therefore the ability for mining to move forward at a cost-effective environment within this electrification space comes down to standardization at one end, and then the ability to work collaboratively to make sure that we get those standards right. We are moving quite quickly, the standards are not keeping up, and therefore the work within CharIN is really trying to write directionally where we want to go, knowing that the standards will hopefully follow.
Thank you very much. Yes, very important. Next question goes to Will. From OMM perspective, why is it critical that we work together on common interfaces rather than developing proprietary solution, and what are the risks if they don't?
Yeah, thank you. From the OEM perspective, we're focused on the equipment. That's what really is driving us forward, and that's what we're really progressing as quickly as possible. In this room together, there's a lot more pieces than just the equipment. And one of those critical pieces that we've been spending most of yesterday talk about is charging and how we get to accelerated, standardized charging. That's a piece that we can't do on our own. We could make a charger, but it'd be different and really be a hurdle rather than an enabler, which is what infrastructure should be for mining decarbonization.
Thank you very much for sharing this. Then from the infrastructure perspective, I can assume there are also challenges, so maybe what are the biggest challenges when interoperability is missing?
Thank you, Alexander. So basically, interoperability enables infrastructure to evolve as a scalable platform. So we can imagine that a good mental model is like Lego bricks. We would like to have a very standardized blocks that we can put together to meet the demands and requirements and the specificities of every mine site, but to have really good, well-defined interface. And we don't mean they're only electrical interface, mechanical interfaces. It is also very important that we have common safety concepts, protection concepts, and data interoperability in addition also to, of course, communication. So in such, when we are talking about lack of interoperability, I mean, we can think about very proprietary OEM systems, which of course have their advantages, but also lock in the miners with a particular OEM, and also on the long term are not very very prone to innovation, do not have motivation to innovate in the technology. If we open up that system without standardizing, we get into a lot of engineering. So we get that every piece, every installation needs to be engineered specifically on every block level, on every interface level. What that means is that we have a lower technology maturity of every installation that we have. We have to do a lot more testing. We have longer lead times. We also have much more complex maintenance procedures. It is much harder to evolve such infrastructure because we always have legacy to take care of. So what standardization and really interoperability means is opening this ecosystem to participation of different parties and also to maturing each and every block. It is also a very exciting time in the electrification in general. There is the technologies maturing from different other adjacent industries and topics, and we need to be ready to also adopt innovation and to bring it and to evolve installations as technology is evolving, electrification technology is evolving. So to have a really future-proof path forward. Also, we must not forget data interoperability as a very critical topic. I mean, this is also an exciting time again in electrification as we are bringing very dynamic loads, new types of loads into our mining electrical system, which require different type of power and energy management, and also give a bit of a different environment that we more see in other process industries than in the mining, with a lot of steady loads. So it is very critical that we have the right way to put this system together and have the system orchestration in place. So yeah, I think that interoperability is much more than only prevention of vendor lock-in. It is really a path for a sustainable innovation in a mining electrification space.
Thank you very much, and I'm very happy that we have so many different perspectives here on the stage, which shows how important it is to work collaboratively on this. Within the CharIN working streams, we are turning the concept of interoperability then into real technical solutions. So this is always what we are thinking about. How do we translate this into real technical solutions? And so for the next section, for the technical part, I would like to highlight that, of course, safety DC arc flash is a very urgent, critical topic. We won't go here into detail, and it will be discussed in another panel. But yeah, important to keep that in mind, that all solutions that have been discussed here now operate within that safety topic. So with that, let's move into the technical part, first with the dynamic charging interface. DCI is about charging in motion, and from an operational perspective, it directly impacts equipment, productivity, fleet efficiency. And so first question goes to Ian. From a mining operator perspective, where does dynamic charging create the biggest operational value on site?
I think dynamic charging, it's a fairly obvious one. A stationary truck does not move any dirt. In mining, we need to keep the trucks running. We need to keep the dirt flowing. The ability to charge while moving allows the economics of battery electrified equipment to become more and more viable. Building an interoperable interface into OEM equipment is absolutely paramount. To allow us to install one dynamic charging system on the side of a haul road is all we have room for. We could not fit 2, 3 different systems on the side of a haul road. We could not manage 2 or 3 systems across a mine site. So the interface points across mining equipment with infrastructure and the equipment is absolutely paramount. Whether it be stationary charging or dynamic, we need a set of clear rules that allow people to plug into those bits of equipment without doing damage to it. So the challenge is what those standards look like to allow a dynamic charging interface to work across all scenarios, and for non-OEM manufacturers being able to bolt onto an OEM piece of equipment without, posing risk to that piece of equipment is very, very difficult. So we wrote the first paper about 2 years ago. We're now about to embark on the next edition of that. We've learned a lot over the last 2 to 3 years of where dynamic charging needs to go. We've seen lots of emerging markets in those areas. I think Blue Vein's out here today with a side mount system. I know likes of Caterpillar and Komatsu and a few other OEMs are working on those systems. ABB's got the overhead systems at the moment, and Siemens. There's lots of systems out there. What is right for any one mine site will be different. So therefore, building that infrastructure and that interface is the only way forward to allow mine sites to work effectively.
Thank you very much on these insights. From OEM perspective, Will, what are the key elements that must be standardized to enable multi-OEM dynamic charging?
Yeah, on the equipment, the way the power comes in is critical. The truck doesn't particularly mind how it gets its electricity, but it does to the operators of that equipment, and changing the way that connection happens for every type of equipment is really difficult and not very feasible. So standardizing connection types, power levels, infrastructure in general, not only stationary charging, but also dynamic charging like we're talking, is critical for enablement and to progress this quickly, rather than, again, just like we talked about in stationary charging, it has an opportunity to be a hurdle or an enabler, and that's what we're after, is an enabler.
Thank you. Adrana, what's your perspective on it from infrastructure point of view? What are the main challenges to make dynamic charging scalable and relocatable?
Yes, so dynamic charging, the infrastructure is, let's say, the biggest topic that needs evolution. Let's say, I mean, as an engineer, I have to say the first requirement for a dynamic energy transfer infrastructure is to carry many kiloamps, to be robust, to be safe, to be to withstand also the mining environment. All of those requirements very much promote bulky solutions. Now there is another part of this equation which says, okay, it needs to be movable, it needs to adapt as the mine evolves, which promotes more lightweight structures, more modular, more connections in the infrastructure. So this trade-off is quite a tricky one. And especially since on one side we have a license to operate topics on safety and robustness of infrastructure. So this basically where this point of trade-off is a difficult one, because there is a lot of also unknowns about carrying so much of doing such a DC transmission in such an environment. We don't know everything about it, and especially we said we will not talk about the protection, so we will not go into it. It is extremely important to do this trade-off right, is to really study this phenomenon, to understand very well how to install this infrastructure in a safe manner, yet such that we have the right return on investment on it. We welcome very much all the activities by ICMM, also activities that are spanning across many other maybe adjacent fields, IC, etc., that are really studying the physics of this phenomena and going against like just interpreting standards in a very conservative way. So this is very important for the evolution.
Thank you very much. I think we did a good work on this for the last 2 years, but we all want to continue. So this also goes out to you. If you want to be part of this working stream, just let us know, and we're happy to continue the discussion on the DCI topic. Let's move to ruggedized MCS. So this is about adapting megawatt charging system to harsh realities of mining environments. So let's discuss this topic. Maybe first of all, Marc-André, because you're also the key initiator of this topic, what does ruggedized actually mean compared to baseline MCS, and what were the key adaptations for mining environments?
Sure. Let me first say it's important to use MCS and not reinvent the wheel and make a new connector for mining, even though MCS is not a perfect fit for mining as is. As mining is different than the street application, as you can all imagine. Street application is kind of friendly compared to mining. We have vibration, we have dust, we have thermal swings, we have humidity, and that causes plastic to crack easily, that causes plastic to swell. So in one moment you can plug in your connector in your vehicle, and then you have it in the mine site, and you can't get it out anymore because you have misalignment. And that's what's happening in mining. That was imperative by creating this white paper to define these tests. And I also, to be honest, we are not perfect yet. We learned a lot the last 2 years and how to improve that. So we have these additional tests, we have additional sealing, and we have also for impact testing, how hard the shell needs to be, how we do this tightness testing. But in the end, we want to have a backwards compatible product that that works in the field. What is also very important in this development is for stationary charging, because we have seen evolving mine sites. And if you need to change or adapt with pantographs all the time, that's quite hard. With a stationary charging, that's a setup time which is quite quick compared to the months of setup. And that's also very important that we have this kind of technology running currently at 6 megawatt, which is more than enough, and not a bottleneck in the field. For stationary charging, also giving a little bit an outlook, what Christian will say maybe later, there's more is possible. So connector will be not the bottleneck in the field. The bottleneck is probably infrastructure or the vehicles, but not with the connectors.
Thank you very much. Ian, what is your take on this? Which operational requirements in mining environments drive the need for ruggedized charging solutions?
Is this one working? Yeah, I think Marc-Andre nailed it pretty well, that the environment within mining just needs that ruggedization piece. We work in a very hostile environment, as Marc-Andre said. We tend to break lots of things. I think the OEMs in the room here can testify to our ability of breaking things. We do a pretty good job of it. So building through standardization and being able to combine the on-highway world and the off-highway world to the mining world is very important. We have on mine sites buses, trucks that will be electrified, the on-highway type vehicles. So being able to be interoperable again across those fields is absolutely important. And I think the work that Marc-Andre has done in this white paper to ruggedize the MCS plug has been exemplary.
Thank you. Vedrana, what is your take? What needs to be considered from the infrastructure side here?
So from the infrastructure side, in the last years, we have worked a lot on automating the connection. So MCS was not really intended from the beginning for automated connection. So this is a certain path that we needed to go. We are now very happy that we have now run a testing of automatic connection using an industrial robot, and we are on over 15,000 basically connections in in various environmental conditions. So this we passed this hurdle, which we didn't know how successful it will be. We are very happy now moving towards the really operational environment where we need to do that under power. And here the challenges are, we need to get to the right reliability. We need to understand all the fallback options that can be done in a safe way, right? So because we have quite a bit different type of a connection where safety needs to be established from both truck and infrastructure side to prove the no voltage condition. Then we need to work on, we need to see, we know that with the introduction of chargers in the public spaces, there have been quite some issues with communication, so we need to make sure that we are very reliable in this area. This is now where the testing is going towards. Yes, and finally, to see how this looks like to integrate a dynamic load of 6 megawatt in the mining grid. So we need to gain operational experience, but we are on the way.
Thank you. As you said, reliability is a big factor here. The question to Will, when designing equipment that can interface reliably with ruggedized MCS system, what are the key challenges?
Yeah, I'll echo my colleagues here that mining is a very rugged environment, hence the ruggedized term for MCS. We compare often to the automotive world where the worst thing that might happen to your charger is you spill some matcha on it as you're going to charge your vehicle. In mining, you know, caked in muck and dirt all the time. So closures, designing that system so it's in a location that's both interoperable with other equipment and accessible for manned and autonomous operations. These are all considerations that we're focused on, and this is the time to nail that part of the design and you know, create this pathway for the future.
Thank you very much for these insights on ruggedized MCS. It was already also mentioned that as we scale further, power level increase, and so do requirements. This brings us to extreme MCS, XMCS. This is clearly a future-oriented topic, and I'm happy that Christian is here today. So at extreme power levels, how do safety, interoperability, energy system constraints come together?
Yeah, so the adventure in XMCS started actually 5 years ago before CharIN came in. So it started with the CharIN-Innovation Challenge, so where BHP, Vale, Rio Tinto, and 20 other companies set out a kind of competition to hand in solutions. And one part was a profile of a, let's say, mining truck, 220-ton payload, which drives 10 kilometers in a mine site and back in half an hour. And it should charge, let's say, the 400 kilowatt hour in 3 minutes. And when you do the math, you come to this 8 megawatts. And we sat then there together. We're also working on the ruggedized MCS white paper. And first we had to find a name for it. And suddenly we came then to X for very large, or XL or whatever, so to extreme megawatt charging. And so 8 megawatt, we said, okay, this must be a complete new system. When you see the voltage level from CCS, 400 volt, 800 volt, MCS is 1250 volts. So we said, okay, now we step up, ruggedized 1500. So we jump up to 3 kV and we say 4 kilo amps, then we are at 12 megawatts. So this was, let's say, the first step to go in this XMCS. And then we started to discussing, let's say, how to do this in what William just said, in a very harsh environment. Where mines are really there in the quite far away from any point of civilization and so on, and you have a mine operation 24/7, 365. And maybe if you followed the Peter Wahlen from Boliden this morning when he said this one mine will have a power requirement of 200 megawatts. 200 megawatts is a city of 150,000 people. Or 200 megawatts is a small data centers. The data centers require now with AI 800 or up to 1 gigawatt, 1,000 megawatts. So the power, how to distribute the power to these mines, this is also, let's say, a very a topic to address. And the other part on the vehicle, 5 years ago, we had to discuss about the batteries. I mean, all the design, what we talk about electric vehicle, it starts from the design. So what size has a battery which can cope with 8 megawatt charging power? So you know C rates in your cars, we have not more than 2 or 3. But here we said if we have 1 megawatt hour battery and we charge with 8 megawatts, so we have 8. A C rate of 8. We know that there are battery chemistry which can consume up to 15, but then was the question, how long will such a battery last? The miners operate these trucks 15 years, and if you have this circle from the CharIN-Innovation Challenge, then you have up to, in a lifetime, up to 200,000 cycles. But you cannot throw the battery after 10,000 cycles away. So there were a lot of constraints, and 5 years ago was a different picture. Battery have really made a lot of progress. I mean, you saw also here from Peter's, let's say, a presentation that there were batteries of 1.6 megawatt hour on the truck. We started in our discussions with 1.2 and think, oh, this is a monster battery. How will this cope? So I see that there's progress, but let's say we have to go further. But I think, let's say, at the moment, this white paper is more of a kind of future a recommendation how to do it. We came to 2 kind of solutions. One is what we know from static charging, like with cars, a plug socket arrangement. But we know from buses, for example, that you have open contacts. So to say, like with pantographs. So we described in this white paper two solutions, but they have to work, let's say, in a rough environment. I mean, buses, for example, who charge with pantographs, opportunity charging, or the flash charging are also working in a rough environment, but not maybe like a mine site, but we have to take the precautions. The other part is 8 megawatt, you don't do it manually. So we knew we have to go into an automated system. And then, how is this functioning in a mine site, automated? Do you need laser guidance? Do you take something more mechanically with funneling in the contact? So there's a lot of variety what we can do. And this was also a topic what we discussed quite long. We talking 3 kV, and there is one parameter, the famous Y capacitance. These were endless discussions in our sessions in the last years. So when the Y capacitance goes to a certain value, you cannot touch, let's say, the charging equipment or the vehicle while you charge. So up to 1,250 volt in MCS charging is possible. We have the recommendation in the RMCS white paper that you need safety gloves. But for sure, you will not handle manually an 8 megawatt charger. So it has to be a fully automated system. And this is a special topic where we still have to work on the safety aspect of XMCS.
Thank you very much, Christian. And on this automated topic, I'm looking again to Vedrana, because then maybe you have also thought about the automation and how infrastructure looks at this. So what role does it play?
Super. Thank you. Yes, I can just repeat, yes, absolutely, we need automation there for these power levels. And also to tell to Marc-Andre, infrastructure will not be a problem at that levels. We will have different ones. In per se infrastructure. Safety is definitely a topic, and such systems we need to operate without human intervention. Also, energy management becomes much, I mean, as we have single units with a much higher power, energy management becomes much more critical to be done in the right way and to not have bottlenecks. I would say, I mean, as we go towards higher and higher power charging, we should probably also move to more autonomous fleets that have very repeatable cycles and then can utilize the energy in the right way. I think this is, but the future will go in this direction for sure with the batteries evolution.
Thank you. Will, what is your take on this from OMM perspective? How do you see the sequencing of XMCS adoption compared to other charging approaches?
Yeah, of course, we're trying to walk before we run, but we're all very excited to start running as quickly as possible, and so that's why we're looking to the future, and XMCS is part of that. And you know, I have a feeling that 5 or 10 years from now, we'll be looking at double XMCS and beyond. It's you know, this is just the start of this pathway, and so yeah, definitely looking to the future.
Thank you. Last question for this topic to Ian. From your perspective, what is needed to consider XMCS ready for real deployment?
I think Will's comment on running and walking, when we started this work, I think Christian had the hardest task of all. It was the future-looking XMCS. We thought we could run fast. We tried running fast, and we came across a few hurdles that weren't supposed to be in the roadway. Things like arc flash, which we'll talk about tomorrow, was one of those big hurdles. And safety within mining is absolutely paramount. So we've slowed down on the XMCS just because we haven't got the technology or the capability to get over those hurdles yet. Some great work being done across CharIN and ICMM on some of those hurdles. I think we just need to get the safety aspects right within RMCS dynamic charging before we move into that next challenge of XMCS.
Thank you very much. So now we come to an end for the technical discussions. So let's bring it back and wrap it up into maybe a bigger picture. We started the session with the interoperability and then dived into DCI, RMCS, XMCS. So maybe Andre, you could help me to wrap it up, and if you could leave the audience with a key takeaway, well, what should they take away from this panel?
for me, it's even if the whole environment and the application is so different, I see, from my point of view, working now 11 years in CharIN, I see some similarities to other industries and involving. And this is mainly, or the key part is the interoperability, bringing now some equipment, some interface on the market, which has a certain power class, which has certain attitudes to withstand the rough, let's say, environment is one point, but to think from the beginning, how can we get this multi-vendor crossed interoperable? What kind of interoperability we need to consider, because it's not only the plug design, it's the communication. Is it one way? Is it two way? Is it backward compatible when, like Will said, we are involving the power classes, the equipment? What do I need in parts of the protocol when I have a fully automated system? So what kind of data do I need to streamline via the protocol? And to always think when, let's say, developing and testing these kind of equipment, this backward compatibility, this is something, my key takeaway from today and some meetings, but also from our roundtable yesterday. We need now to find a solution, multi-vendor, cross-industry driven, how to align on a certain, let's say, test scenario. When is the product interoperable? And what we learned in the past is every site, infrastructure, OEMs can say, I made the right implementation of my standard. That's one thing. That doesn't mean automatically that it's interoperable. So we need to consider an industry, let's say, effort to say, okay, this is, because we cannot copy it from the cars and from the trucks, because there you can move the equipment much more. You are talking about complete different volumes in market. So we need to find a different way to say, here's the alignment, here is the test spec, and if we do this in that manner, it's okay to use it somewhere. And then to go to the different standardization bodies and get a safety certificate, to get all the additional layers of interoperability. But first we need to have this kind of, is the equipment talking to each other in the right way and under all conditions? We need to align that. And that's my key takeaway, where we, I think, find or will find together ICMM, CharIN and all the players involved. We need to find an answer within the next 12 months, my guess, how to do that.
Thank you very much for the discussion and also for the wrap up. Looking at the time, are there any questions from the audience?
We've got time for one question, and I know it's probably going to be quite a popular one. What is CharIN doing to ensure charging interoperability with Chinese OEMs?
The same way like with all other OEMs. So CharIN is an open association. Everyone who likes to join, we have an agreement with ICMM when it comes to mining specific topics. So every company can join CharIN, and maybe ICMM is different, but can join the association and can put their contribution to the table. And when, like I meant before, it's not a closed shop, so everyone is invited. You need to become a member to be part of the, let's say, deep discussions, but there are also formats and public available information like white papers where everyone can referring to. So we see this outside of mining. We have a lot of, let's say, international members, including, of course, Chinese members. So it's an open approach from my point of view.
Excellent. Thank you very much for that. Thank you, Alex, for steering that conversation with 6 panelists. I know that was quite difficult to get that in within 40 minutes. Tom, I would love to give the mic to you, but I can't. I've got to keep us on time. Thank you to the panel. Please give them a round of applause.